Hi, welcome to my channel. This is Obro, and today we are going to continue with the remaining part of the three-phase induction motor which we started from the last class. Now I'm going to start with the next question. So this will be the question number 3 or question number 4. That is a center zero ammeter. A center zero ammeter connected in the rotor circuit of a 6-pole 50 Hz slip ring induction motor. Slip ring induction motor which makes 45 complete oscillations. 45 complete oscillations in 1 minute. In RPM, the rotor speed in RPM, the rotor speed and the speed of stator field of rotor are. So these are the specifications given here. P is equal to 6 pole, F is equal to 50 Hz, then number of oscillations per second is equal to 45. So now we are going to find out the F dash. F dash is nothing but that is the rotor current frequency. Rotor current frequency, that is 45 divided by 60. So if we can divide this one with 5, 9, 12, 3, 4, that is 0.75. So we can find out the value of sleep. Sleep is nothing but S, that is F by F dash. To check the value of the sleep, that is F dash by F. So F dash is, we have already found out, 0.75, and frequency is here already given as 50 Hz, 50. So if we can divide F and F dash, we will get the value 0.015. This is the sleep. So from here we can find out the value of Ns, that is the synchronous speed. Ns is equal to 120 F by P. So it is a 120. What is the frequency here? Frequency is 50 Hz. 50 divided by, what is the number of pole? Number of pole is 6. So if we can divide this 20, this is 1000. So if we can now we have to find the rotor speed. Rotor speed is equal to Ns 1 minus s. So ns value is already we have come to know that is 1000 into 1 minus 0.015. So if we can calculate this one, so it is 1000 will remain the same value into if we can deduct 1 minus, so what will be the value? That is the 9.985. So if we can calculate this value, that is 985 RPM. So what they are asking at the end, that is what is the speed of the rotor field. Speed of the rotor field, we can write here speed of the rotor field, that is ns minus nr, ns minus nr, ns is equal to 1000 minus 985. So this is 15 RPM. So I hope you have understood the full numericals how we have done. These are 6 pole 50 Hz slipping induction motor, makes 45 complete rotation oscillations in 1 minute. We have to find the stator field speed. So we have just find out ns is equal to 120 f/p. So we have synchronous speed is 1000 RPM, and this there is a rotor speed nr is equal to ns into 1 minus s. So 1000 is already we have found out here, and 1 minus slip we have found s is equal to f dash by f. F dash is nothing but the rotor current frequency, and so from here we have calculated the value of slip, and from here we have found out the rotor speed, and then the speed of the rotor field ns minus nr. So it is 1000 minus 985 RPM is 15 RPM. So I hope it was very easy numerical. So I'm going to proceed with the next numerical. So what the next numerical says? Next numerical is the supply voltage to an induction motor. The supply voltage to an induction motor. The supply voltage to an induction motor is reduced to 10%. Is reduced to 10%. Is reduced to 10%. So what is the next part of the question? So what percentage approximately will the maximum torque decrease? What percentage will the maximum torque decrease? So we have understood the question. The supply voltage of the induction motor is reduced by 10%. So how much the maximum torque will decrease? So we know that the value T is directly proportional to, that is the torque, that is the V square. This is the we know this part. So what is the other part? That is the T directly proportional to, so is already reduced by 10%, that is 0.9 whole square, that is 0.9 V whole square. So this is because it is reduced by 10%. So it is reduced by 10%. So now it will be the value T dash by T is equal to nothing but 0.9 V this whole square by this V square, that is 0.81. So 1 minus T dash by T is equal to 1 minus 0.81 is equal to 0.19, that is nothing but 19%. So I hope you have understood how this has been calculated. because T directly proportional, T is nothing but the torque that is proportional to V square. So T directly proportional to 0.9 V square because it is reduced by 10%. So T dash by T is equal to 0.9 V divided by V square overall square. So if we can deduct this, so it will be 0.81. So 1 minus T dash by T, torque dash by torque is equal to 1 minus 0.81 is equal to 0.19. So ultimately it is reduced by 19%. So I hope you have understood how we have calculated the torque and other numericals which I have taught here. So I'm going to end my video here. So we are going to continue the next class. Thank you. So thanks for joining us. This is Abro. Until next time, keep on studying. Thank you very much.